Hello Internet. Let's talk about the pyruvate dehydrogenase complex, or PDC. It's a group of 3 enzymes that's probably one of the most important parts of you that you've probably never even heard of. In 3 minutes, we're going to find out why. To understand why PDC is so important, we first have to learn about metabolism. That's eating, drinking, chomping, nibbling, pretty much any kind of consumption of food and the breakdown of those components into energy. But that's a lot of words and not a lot of time, so here's a donut. Now, I for one like my donuts full of sugar, which is convenient because sugars are actually one of our main energy sources and are broken down in our cells like so. First up, glycolysis. Something you've probably heard of. Sugar goes in, a molecule called pyruvate comes out. Pretty basic, nothing too complicated. Next is PDC. Our star of the show, pyruvate goes in, acetyl-CoA comes out, but we'll come back to that. Acetyl-CoA then goes into something called the citric acid cycle, which creates some very important products for something in our cells called the electron transport chain, which will give us energy or ATP. So with all that in mind, time to zoom in a bit. This is PDC. Well, to be more precise, PDC really looks like this. On paper it looks like this, but that's a headache, so for our purposes it looks like this. 3 enzymes appropriately named E1, E2, and E3 all stuck together, all working together with the simple task of turning that ever so important molecule pyruvate into acetyl-CoA. The first step is taking that pyruvate molecule, a special little molecule called TPP, putting them in a room together and setting the mood. TPP will replace a CO2 group on that pyruvate and be passed on to the next subunit. Approaching our now carbon skeleton with TPP stuck onto it is a lipoamide molecule. Basically, it's something with a couple of sulfur molecules that accepts that carbon skeleton that TPP was holding onto, and similarly passes it along to a molecule called CoA. This process creates our important product, acetyl-CoA, that gets shipped along to the citric acid cycle. Okay, so we've turned our pyruvate into acetyl-CoA. Well, what's the point of E3? Well, the passing along of the carbon skeleton leaves our lipoamide with some hydrogens attached, which is a problem because we need those removed in order for E2 to work again. E3 essentially reloads E2 by taking off those hydrogens and forming some molecules called NADH and FADH2, both very important to the electron transport chain we talked about, but more on that another time. Okay, granted, there are other ways to get energy from food. Donuts also have fats, for example. Another high energy source that, while not taking the same path as glycolysis, will instead use a process called beta oxidation, which will still also produce acetyl-CoA, just like glycolysis, which can still be turned into energy, same as before. But without PDC and using beta oxidation alone, you'd be completely wasting any sugars you're eating. Now, without PDC, you can still make energy from sugars through a process called lactic acid fermentation, but it's not nearly as efficient as using PDC, and you end up with lactic acid buildup. You might be familiar with this as that muscle burn you feel when you're running. With the part it plays in generating energy, PDC is so important that mutations that disable PDC are mostly fatal. And even if your PDC is kind of working, you're still going to experience symptoms like muscle weakness, respiratory infections, and fevers. And important side note, the brain relies almost solely on glucose for its fuel. No glucose, no brain. So deficiencies in PDC lead to deficiencies in glucose levels, which causes neurodevelopmental delay and structural brain damage. So thank your PDC for all the hard work it does, take care of yourself by eating a balanced diet of foods, and maybe treat yourself to some donuts now and again. After all, you need the sugar.